You just couldn't stay away, huh? You wanted more of Mr. Larkin. I don't blame you. Nobody else does. We all understand. Let's talk about J.J. Thomson. It's a fun name. J.J. Alright, so this is back in 1897, which is over 100 years ago. Good golly gosh. Cathode ray experiment. Like a laser? I don't know what a ray is. Like a ray of light? I don't know. Okay. On each figure below, talk to the text. Hello, text. How are you? What are you doing Friday? You want some pizza? No, not like that, you silly goose. We want to annotate. So on this figure, I'm thinking maybe this right here. I'm going to outline it. Maybe this is the cathode ray, because it looks like a laser essentially. And then, I mean, it's curving, so that's important. I don't know what else I can learn from just the figure. So, all right. So J.J. Thomson passed a stream of electric current, so electricity, through many types of atoms in a vacuum tube. I know vacuum means nothing in there, right? It's like some of your heads. No, just kidding. You all are very intelligent people. Why else would you be watching this video with your growth mindsets? You're not a vacuum head. That would be an interesting insult, though. Don't use that. Okay. When he did this, he observed a glowing ray called the cathode ray. So I was right. This is the cathode ray. Come out of the atoms. The cathode rays passed through thin sheets of foil. So J.J. Thomson knew the cathode rays were made of particles much smaller and lighter. Okay, so they went through sheets of foil, so that means they're smaller and light. So tiny particles are coming out of atoms. That sounds weird. Let's look at this next one. So when J.J. Thomson exposed the tiny particles in the cathode rays to positive and negative charges, so here are the positive, here are the negative charges, they were attracted to positive charge. Ooh, so this is an attraction. Oh boy. So positive, I know opposites attract, so this has to be negative. And repelled by negative charge. He reasoned the small particles were negative. Yes, just said that. Since they were attracted to positive charge. He called these negative particles electrons. Interesting. Well, what did J.J. Thomson discover about the atom? You better be able to know that. Seeing as we did this in class, this is just review, I better hope you know that. What did J.J. Thomson discover, and which model can we eliminate? Well, based on his discovery, one of them doesn't have it, so you should be able to cross it off. All right, let's talk about my boy Rutherford. So this is like 14 years afterwards, and he's doing this gold foil experiment. Okay, it says in the early 1900s it's discovered that certain types of rocks emitted positive particles called alpha particles. Just by the way, this is called radioactivity. We might study it at the end of the year. These positive particles contain two positive charges and had the same mass as a helium atom. So I'm assuming this is an alpha particle. I see the two positives right there. And two orange ones, I don't know, okay. Rutherford fired a stream of alpha particles. Okay, so this is the alpha particles. At an extremely thin, I can't read and write at the same time, particle. An extremely thin piece of gold foil, so there we go. About 99% of these particles went straight through. So this is 99%. But 1% were deflected, bounced, so bounce means deflected, to the side or backwards. So 1% bounced. Interesting. Wonder where they bounced off. Why did this many go through? Why didn't they all bounce off? Huh. Alright. Rutherford reasoned that since most of the alpha particles went straight through the foil, most of the gold foil was empty space. Ooh, that sounds important. So, well, gold foil's atoms, right? So atoms equal mostly empty space. Green, like the color money. like Mr. Marquez likes to grade in. Alright, but what was causing the alpha particles to bounce to the sides or backwards? Right, because if it's mostly empty space, they just all go through. He realizes some of the alpha particles were hitting a dense, I know dense means really compact. What just happened there? Dense means a really compact, so small and heavy means compact. Positive center. Okay, it has to be positive because they have to repel. That makes sense. Alpha particles repel. Otherwise, they wouldn't bounce. They'd stick. He called this the nucleus. So what did Rutherford discover about the atom? Which model can he eliminate? Again, you should know these. If you don't, you better figure it out right now and be ready for next class. All right. Love you. Bye-bye.